Okay, so with the help of this example, we are going to find out the effective addresses for the different addressing modes that we have. So we'll start off with implied. Now, naturally, in implied, there is no question of finding an effective address because there is no effective address. Okay, the address of the operand is implicit, or it is already implied in the instruction itself. The second one is immediate. Immediate addressing mode. So if you look at this instruction here, let us look at this instruction here. So you can see this represents memory. This is main memory. So you have addresses 200, 201, 239 and so on. So from address 200 and 201, it indicates one instruction. So the first part of it contains the operation, that means load to accumulator. So that is the operation to be performed, load to accumulator. Then comes the mode field, okay, and then comes the address field. So there are three fields: operation, then mode, and then address. So it is definitely not implied, okay, since it says load to accumulator. Now to load what do we want to load to the accumulator? That is not given, so this is not implied. So let us take the next addressing mode to be immediate. So immediate, if it is immediate, then the address field, instead of holding the address of an operand, it contains the actual operand. So if it is immediate mode, after execution of this instruction, accumulator will have the value 500. Okay, why? Because this is the operand. This is the value that has to be loaded into the accumulator. So this is your this is your immediate this is your immediate mode. So the address is in the the operand is in the address field itself. So okay, so now let us see the third one. The third is register. If it is register, then here address of, say, instead of having address equal to 500, okay, we will have R1. We'll have the address of R1 here. Okay, register R1. So in that case, what will be the effective address, or what will be the operand? So effective address is R1, and the accumulator will hold the contents of R1, which is 400. So contents of R1 is 400. Okay, so this is if it is in the register mode. So instead of 500 here, it will hold the address of R1. Next, let us see register indirect. So if register indirect, so in that case the effective address would be, if you can recall, register, so this is not there, you have R1 here. So effective address would be what? Go to register R1, whatever is the value there, go to that memory location, and then this is the actual operand. So the address, at which address we found 700? At address 400. So 400 is our effective address. So effective address will be 400. And what will we load into the accumulator? We will load 700, because at address 400 we have the value 700. So this is your register indirect mode. So in the address field you have R1, go to R1, take the value there, go to memory location with that value and take the value which is there, 700. Okay, so the next one is now that we'll look at is our auto increment, auto decrement. So auto increment, auto decrement, if we use the same as register, R1 as the register, then everything remains the same. this is exactly the same as this register. Okay, accumulator will get 400. Only thing that will happen is that the contents of register R1 will now it was containing 400, now it will contain either 401 if it is auto increment or 399 if it is auto decrement. So only the contents of register R1 will change, whereas our effective address and the contents of the accumulator remains the same. Okay. Then let us come to direct. So in direct addressing mode, we have to look at what is here. So the address field contains the value 500. So if you can recall 500, you have to go to memory location 500. Okay, and this is our operand. So effective address in case of direct, effective address is whatever is there in the address field, which is 500. And what will the accumulator contain? Accumulator will contain whatever is there in address 500. Address 500 contains 800, so this is 800. So this is in case of direct. What happens if it is indirect? You just have to move one more level. So effective address would be, so just if you remove this thing, so 500 is there in the address field, go to address 500, take out this value, go to this address 800, and this is our operand. So go two levels, so 500, go to address 500, take the value, go to this memory location and get the value. So here the effective address was what? Effective address was 800 and accumulator will contain what? 300. Accumulator will contain 300. So this is in case of direct. This is in case of indirect. Then we have relative. Relative, the effective address is the contents of the program counter plus the address field. So what is there in the address field? In the address field I have 500 and the contents of the program counter, here you can see it is 200. So it will be 200 plus 500, which is 700. Alright, and the accumulator will contain, so we'll go to address 700, so it is 500 plus this gives me 700. Okay, alright, 700 is not here, okay, so 700, and I'll just explain why this is coming to 702. It is going to 702. Okay, to understand this, why it has gone to 702, let us look at this. Let us look at this instruction. Okay, see, address 2000. Now, sorry, 200. It is at address 200. To next instruction where it starts at address 202. Now, if you can recall our fetch, decode, and execute cycle, then you will notice that in the fetch cycle, after this instruction, the instruction to be executed is being fetched, the program counter is incremented to point to the next instruction. So the value of the program counter would not be 200, instead it would be 202. Why not 201? Because 201 location is a part of the instruction. So the next instruction starts at 202, so its address is 202. So that means when we try to execute this instruction, okay, the value of the program counter would not be 200, instead it would be 202. So that is why we add 500 and 202 and we get 702. So we have in case of relative, we have, instead of 200 we have 202, 202, so we get 702. So in address 702 we have the value 325, so 325 would be loaded into the accumulator. Then the remaining, that is indexed and base register. So we have XR can act as either a base register or a index register. Okay, so here this is our base register or index register. So what we do, 500 plus contents of this, so this gives me 600, so 600 gives me 900. So this is our operand. So effective address is 600 and operand is 900. So in case of base register, it is effective address is our 600 and the contents of the accumulator would be whatever is there in address 600, which is value 900. And if it was indexed mode also, we are going to use the same register XR. So the process is same. So the effective address is same as well as the operand is the same. So this is an example where you can see how the effective address can be calculated according to the different addressing modes that are present.